Hey guys, we are going to talk about thyristors and SCRs today. There has always been a confusion with many of the students in electronics who are not very clear of how this works. So we are just going to take a small detailed look on the application side of how to trigger this SCR or thyristors and how they behave. So let's start. As you can see here, this is the symbol of an SCR or a thyristor, and this part, it is similar to a diode but with an additional pin called gate. So this is the anode and this is the cathode, and this is what is the gate. Ideally, this could be these current passes from the anode to the cathode if the gate is triggered with sufficient voltage and current. Now let us have a look at this application, how we have done this. Here you can see that we are generating a 50 Hz sine wave frequency on the anode, and the cathode is connected to a load of 20 ohms. Now we have connected a resistor from the gate to the load side. So what happens here is you're pulling the gate voltage down by 6K resistor and very low ohms on this side, 20 ohms in this case, to ground. So when there is no voltage applied here, you are actually keeping the gate at a lower level. So what happens when there is a sine wave generated and there is no voltage here? Ideally this should not conduct and there is no current flowing from the anode to the cathode, except for a few small leakage current that could occur. Could be in micro amps. So let us take a look here. What we have done here is we are generating a small pulse, a square wave pulse of a period of 1 millisecond pulse width, and the period is about 40 milliseconds. So it's just a short pulse that we are generating, and this short pulse is given to a 1K resistor to the gate. Since this is at a lower resistance than this, the potential at this point should be higher if the voltage here is sufficiently higher. In this case, what we have done is we have given just 1 volt at the pulse, 1 volts pulse, and this is dividing, and the voltage here is much smaller. We'll look what happens. Before that, I would like to know, I want to explain to you that the starting pulse or the starting point in this case here is set at almost 0. That is the time delay at startup is 0. That means we are trying to sync with this pulse at all times. Okay, now let us have a, we'll simulate this circuit and see what happens. Now this is the simulated results that we have. This is the AC supply. This is the AC supply. uh, 40 volts amplitude and 50 hertz frequency. There's no delay. So since there's no delay, we are starting at a 0 point, amplitude at 20 volts positive, 20 volts the negative side. So this is the input supply that we are giving, and here you can see the switching pulse. The switching pulse is basically we are giving only a positive pulse. So we are not generating a sine wave, we are generating just a positive pulse. So here the amplitude is 1 volt, time delay is 0. So you could see that at the 0 starting point, this pulse goes to 1 volt, comes down, and there's a 40 millisecond delay that we are having, almost 40 minus the 1 millisecond pulse. So after that it generates one more pulse. So let us see, the interesting part is at this point what happens. When this 1 volt pulse is generated, you have at a 1K resistor, that is the red point, that is the, yes. So let's see the pulse at this point. So basically is less than 20 millivolt for a 1 volt pulse that we are giving. Basically it is in an off mode state. There is no conduction as such, except for the small leakage current. It is specific to the device that you choose from. So let us see what happens when we increase this volts to about 10 volts. We do a quick simulation, and you can see the voltage at this point is the gate pulse, which is actually 10 volts. So the gate pulse here triggers and get hold, and the sine wave, which is the same because this is the input voltage, and the output voltage swings to the positive side because this works as a rectifier. It can't pass AC waveform because, as I told you earlier, is more of a diode, and it rectifies and passes only the positive cycle, the positive pulse or the positive voltage of the sine wave that we are generating here. Now let us have a let us see what happens when we at the current level. So we'll put a current probe here at this load, and see the you can see here that the current probe that we have put at the load is basically at the pulse part and how it behaves. So you can see here that the current at the load resistor is about 1k, 1 amps peak, and this is with respect to the half sine pulse that we are generating on the inputs. So amplitude goes to 20 volts. The current here is about 1 amps. So the current is dependent on the load resistor, and this should be selected according to the device maximum operating current with all the safety margins. We'll look at that at a later stage in a separate video on this. But to understand how this system works and where it could be used, we'll have a little more detailed look into it. Now you can see here that the sine wave is generated here, and the pulse at the output or at the load resistor is on the positive cycle of the sine wave, and the second cycle there is no output on the second cycle. On the third cycle, yes, you have another pulse because your gate pulse has been triggered accordingly, and this is the current. Now voltage and the current gives you the power. Now we are reducing the power because we are skipping one cycle. Now if you start skipping 2, 3, 4, your power to the load is reduced, of course, with the power interrupted. You could put a capacitor at this point to smoothen out, to get a pure DC without pulsating, and that will depend on the kind of current that you are taking and the capacitor's storage capacity. So this is how you can control the power into a load, just by triggering the pulses. Now when you trigger these pulses, what happens is, when the positive pulse comes here, this switches on. So you can look at this point. When pulse starts, triggers, switches on, then you get a 0 point at this point. At the 0 points, your SCR stops conducting, and then the negative part starts, and again a positive part starts. But still, since it has been already reset, there is no conduction at all at this point, until and unless your second gate pulse comes to trigger the whole system in place. So if you skip this to probably at this point, then the output will be 0 until the two pulses are skipped, or two waveforms are skipped. So what we could conclude from this learning process is that it's a rectifier, but it triggers only on the gate pulse, and if you're giving a sine wave at the input, every time the sine wave goes to the 0 point, this resets, and you could control the power to the load with the help of the timing pulse that you generate on its gate. So that's all, folks. If you have any questions or queries, please let me know, and thanks for watching the video. Thank you.